The topic of this video is joint and marginal probability distributions. And as I go through it, there's going to be a lot of notation. But see if you could focus on the big picture and not get too tripped up by all of the notation. So we're going to begin with this table here, which is some data on 1,000 trees that were cross-categorized according to species and height class. So in terms of species, we've got 3 species: aspen, spruce, and pine. When it comes to height class, we've got 2 height classes: less than 170 centimeters and more than 170 centimeters. And if we look at this final column here, we've got marginal totals. So if we add the 200, the 300, and the 50, we've got 550 trees that are in the height class less than 170 centimeters. And similarly, if we think about this bottom row, this 450, if we consider the spruce species, we've got 450 individuals that are spruce. So this all relates to the counts. Well, we can convert from counts to probabilities simply by dividing each one of these numbers by 1,000. And that gives us this table here, where now we've got probabilities. And so what I want to begin with is this concept of joint probabilities. Okay, so let's think about this number 0.3. What does this number 0.3 mean? Well, that means, and the way to think about this is to think about the word and. So if we were to select a single tree at random from this population of 1,000, the probability of getting a tree that was simultaneously a spruce and height class less than 170 centimeters would be 0.3. So in the body of the table, all these values of the body of the table represent the joint probabilities. The probabilities of a randomly selected tree having some value of species and some value of height class. And the way we often represent this, going into some notation, is PSH, which means we've got a random variable capital S and a random variable capital H, and this is the probability of when we select our single individual tree of getting a particular value of big S, that I'm going to represent as little s, and a particular value of big H that I'm going to represent as little h. For example, if we want to consider this value 0.3, where would that come from? That would be probability SH equals probability. The value of S is equal to 1. The value of H is equal to 0. And we'd say that is equal to 0.3. And so we've got an alternative representation that's shown in your notes, and you can see that here. Here we've got, if we substitute 1 here and 0 here, 1 here, 0 here, we get that value of 0.3. So that's the essential concept of joint distribution. The thing to focus on is this word and. The fact that a single tree selected at random is going to have a probability shown here, which is having this value of species and this particular value of height. So now what I want to do is think about marginal distributions. If we come back here, clean this up for just a little bit. Take me a second to clean this up. Okay, if we think about marginal distributions now, those marginal distributions, marginal probabilities, are the ones that are shown in the margin. And you can think of the marginal distribution as being the overall probability that a randomly selected tree will be in a particular species or in a particular height. And so you can see, just looking at the table, if you were to randomly select a tree, the probability of it being in this particular height class would be this marginal value right here. And similarly, the probability of a randomly selected tree being a spruce tree, we would find that in this margin, it would be right here. And again, that's the overall probability. So you find the overall probabilities, the marginal probabilities, you find those sitting out here in the margins. So again, a little bit of notation. Notationally, we can represent this as, for example, P S1 equals probability S is equal to 1, and that's going to be equal to 0.45. So what does that mean? So here we're thinking about the probability. And what we're going to do is we're going to put some value in here in this function, and that's going to return a probability. And what we want to do is we're focusing on species. That's what this S is about. So we're thinking about species. We're thinking about one of these three species, and we're specifying that the actual value of S when we do the experiment is equal to 1. So we're thinking about S is equal to 1. And so what that means is when we do the experiment, the probability of this random variable capital S will actually take on this specific value of S is equal to 1 is equal to 0.45. And again, there's an alternative way to look at it. Here you see all the possible marginal probabilities for the different height classes and different species. And here you see that the probability of getting a spruce, the marginal probability of getting a spruce, is equal to 0.45. Now what I want to do is just a little bit more notation. I'll do a little bit more notation, and I want to think about how you might calculate PS1. So how are we going to calculate PS1? So obviously, what we're going to do is we're going to add 0.3, the 0.15, and we're going to get the 0.45. So the big picture is important. We know what we're going to get. But let's think about some notation. Notationally, what we're going to do is we're going to take the sum of all the values of P1H over all H, and that's going to be equal to 0.45. So what's happening here? So this is the joint distribution. This is a joint distribution of species and height class. And what I'm saying in this expression is let's keep the species constant at 1. We'll keep the species constant at 1, and then we're going to sum over all values of H. We're going to sum over all values of H, and that's going to give us 0.45. Let's try another one. Let's try PH0. So what's that going to be? We're wanting the marginal probability of this height class less than 170. So we know what the answer is, 0.55. But let's just think about the notation. What it means notationally is, again, if we go back to our joint distribution, where we've got all possible species, now we're focused on height class 0. We're going to sum over all S. So what we're saying is, okay, we're going to fix the height class at 0, and then we're going to sum over all of these different values of species, and that's going to give us 0.55, which is the marginal probability of having a tree with a height class less than 170 centimeters.